Hello, my name is Shlok Shah, and I will talk about bridges today. These are the topics which I'm going to cover in my presentation. Bridges are the marvel of engineering that have been around for centuries, which connect people, places, and culture. They serve the essential function of connecting people and places across physical barriers like water bodies, roads, valleys, and railroad tracks, etc. Stability, strength, and sturdiness are the most important characteristics of bridges. They must be built strong enough to support their own weight, as well as the weight of people and vehicles passing over it. The design of the bridge considers various factors, such as the geological conditions of the site, the climatic condition of the area, span and clearance of the site, materials availability and budget, construction time, frame, traffic demands, etc. Wood, bamboo, bricks, steel, concrete, and glass are the materials used in bridge construction. Arithmetic, algebra, and geometry are the main mathematical concepts used in bridge design. There are two kinds of bridges, fixed and movable, and both have different types of bridges. Beam bridges are the simplest and most common types, consisting of a flat deck supported by beams at each end. Arch bridges are known for their strength and elegance, using curved arches to distribute weight evenly. Cantilever bridges use rigid beams projected outward from supports. Suspension bridges are ideal for long spans, with their decks suspended from tall towers by cables. The earliest bridges ever were the pedestrian bridges. Construction of bridges involved several steps like planning and design, site preparation, foundation, substructure, superstructure, and completion and inspection. To understand how the length and strength of bridge are related, I conducted a paper bridge experiment. I used fixed width and different lengths of paper bridges, pennies, paper cups, and two books of the same thickness to conduct the experiment that how many pennies will be held by different lengths of bridges. My hypothesis was that the 6-inch bridge would hold the most pennies because the 6-inch bridge paper strip was neither very long nor very short. Here's the result of my experiment. The 5-inch bridge can hold the most pennies, and the 11-inch bridge can hold the least pennies. My hypothesis was not correct. I learned that when bridges have a shorter span, they can hold more load. Now, let's talk about the tied arch bridge. A tied arch bridge is a type of bridge that has an arc width on each side of the roadway and one tie beam on each arch that supports the deck. These are the main components and structural behavior of the tied arch bridge. Let's watch the video explaining both. Here are the key components of a tied arch bridge. The arch, a curved structure supporting the bridge's vertical load. It is typically a parabolic or elliptical shape. Tie, horizontal elements stabilizing the arch and distributing forces. Deck, the bridge's roadway or walkway. Hangers, the vertical or inclined members connecting the deck to the arch. Braces, which connect the arches. What is the behavior of the bridge? When the load is applied to the deck, it is transferred to the arch via hangers. This creates thrust in the arch, which is balanced by tension in the beam. The advantages of the tied arch bridge are: the tied arch bridge design effectively distributes the load, which gives structural efficiency. It has a visual appealing design. It can span a greater distance without the need for intermediate support. It has flexibility in design and minimum maintenance needs. The curved shape of the arch and tie provides inherent stability against natural forces. It can be built with a variety of materials. I chose the tied arch bridge because they offer a captivating blend of aesthetic appeal, engineering innovation, and cultural significance, which make them unique and fascinating structure. Here is a concept drawing of my tied arch bridge. I used 103 popsicle sticks and approximately 4 ounces of glue. This is a 3D design and model of my bridge. Finally, Here's my tied arch bridge model. The arches are connected to ties. Hangers are interfaced with the deck and the arch. I have used a 1:2 ratio of rise to span. Horizontal braces are connected to arches. There's a floor beam with the deck. To check the strength of my design bridge, I conducted a weight test. I conducted tests in both top loading and suspended weight tests. Let's watch the videos.
Hello, this is a tied arch bridge that I designed and built using 103 popsicle sticks. So, this tied arch bridge has a very sophisticated design that I would like to test out. We are going to test its strength. So, here I have 4 to 5 2.5 pound dumbbell weights. Let's start. The first one, 2.5. The second one, 5 pounds. The third one, 7.5. The fourth one, 10. So here we clearly see that this bridge can hold 10 pounds. But just to see how strong this is, I'm going to put one more dumbbell weight to make it 12.5. And boom, we can see here that this bridge can hold 12.5 pounds and maybe even more. Thank you. First test, we put it above the deck. And now in our second test, I will suspend the weights down here below the deck. So let's start. 1, 2.5. 2, 5. 3, 7.5. And 4, 10. Here we can see the bridge efficiently and strongly holds 10 pounds. Thank you.
As a result, my tied arch bridge can withstand a significant load of 12.5 pounds. Weight in both compression and tension testing methods. Here are a few fun facts about tied arch bridges. The Qiaotianmen Yangtze River Bridge in China is the world's largest and longest tied arch bridge. The Sydney Harbour Bridge appears on Australian $2 coins. The New River George Bridge in West Virginia is the highest tied arch bridge. Tied arch bridges have a great history, rooting with Roman empires. Roman examples like the Pont Fabricius, which is still in use and standing today. Here's the list of the online resources I used. Hope you learned something new and fascinating regarding the bridges and especially the tied arch bridge. Thank you!